Okay, so what if our strongest materials weren't forged in a furnace, but were actually grown in the ground? Today, we're going to dive into a pretty fascinating experiment that does exactly that, creating these high-performance structures out of mushrooms and wood. Let's see how they pulled it off.
And this really is the central question here. Can we actually build strong, load-bearing structures using only natural, biodegradable stuff? I mean, that's a huge challenge for modern engineering.
And you know, there's a really good reason to be asking this. A lot of the high-strength composite materials we use for everything from cars to buildings aren't exactly great for the planet. They take a ton of energy to make, and they're definitely not designed to break down. So the hunt is on for a better way. So, how do you do it? Well, researchers started with a surprisingly simple, all-natural recipe that's actually inspired by a classic engineering design. And that design is called the sandwich composite. The concept is actually really straightforward. You take a lightweight, kind of thick core material, and you bond it between two thin but very strong outer layers. They call them skins. What you end up with is something that's both lightweight and incredibly stiff.
So, what are the ingredients in this all-natural sandwich? Well, for that lightweight core, they used a foam grown from fungal mycelium, which is basically the root structure of mushrooms. For the strong outer skins, they went with thin sheets of hardwood, like oak and hickory. And then, to stick it all together, they needed a special glue.
An adhesive they whipped up right in their own lab. And get this, the recipe was as simple as something you'd find in a kitchen cookbook. Flour, sugar, and water. Seriously, that's it. This entire structure is 100% natural, from top to bottom.
Okay, so you've got your mushroom sandwich, held together with some simple homemade glue. The real question is it actually strong? To find out, the researchers put it through a whole series of intense stress tests.
First up was the bend test. This measures something called flexural strength, which, is really just a fancy way of asking how much can you bend it before it snaps. They just applied force right to the middle of each sample to see where its breaking point was. Now, what's really interesting here is how the materials failed. It tells a story. Look at image B, the one with the thin oak skins. You can see the core itself just sheared apart. But then look at C and D with the thicker wood. The failure mode totally changed. The wood skins actually started to peel away from the foam core, a process they call delamination. This shows that the glue and the bond were the weak points, not the stronger wood skins.
And the results from that bend test? They're pretty dramatic. On its own, the mushroom foam is, well, it's pretty weak. But the moment you add just those thin oak skins, its ability to absorb energy before breaking jumps by 10 times. And the one with the thick hickory wood, it performed the best of all. It's just proof that the sandwich design is incredibly effective.
Bending is one thing. That's great. But for some applications, you need a material that can handle a sudden, high-speed impact. So now it's time for the ultimate test. Could this thing take a direct hit from a projectile?
And we are not talking about a little tap here. The researchers fired a .45 caliber projectile at these samples at speeds up to 167 meters per second. To put that in perspective, that is over 370 miles per hour.
The visual evidence here is just so powerful. On the left, you see this messy, blown-out hole in the plain mushroom foam. But on the right, look at the exit wound on the hickory sandwich. The damage is so much more controlled, with the cracks following the grain of the wood. The wood skin just contained that impact way more effectively.
So, after all that bending and blasting, what's the final verdict? Let's break down the performance results.
So the key findings are pretty remarkable. Just adding the wood skins made the core over 7 times stronger. The stiffer hickory wood was the clear top performer. And this is fascinating. The foam itself is rate dependent, which means it actually gets stronger the faster you hit it. It absorbs more energy from a high-speed impact. But maybe the biggest takeaway is this. These natural sandwiches absorb several times more impact energy than some of their synthetic counterparts, like the ones made with fiberglass. But if there is just one number you should remember from all this, it's this one, 95%. So what does that mean?
It means that when they used those strong wood skins, the area of damage on the back side of the panel was reduced by a whopping 95%. In other words, the wood acts like armor, protecting whatever is behind it from the hit.
So what does all of this mean for the future? I mean, these results are way more than just a cool experiment. They're pointing toward a whole new way of building things.
The bottom line is that this study shows that materials that are 100% natural and fully biodegradable can have some seriously promising performance, even for jobs that need to bear some significant weight.
And that leaves us with a really fascinating final thought. If we can get this level of performance with just mushrooms, wood, and a simple glue made of sugar and flour, just imagine what else we could build with biology. Really makes you wonder, what's next?